Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Kindly turn on your videos, children. Nandana always joins with her video on. Very good, Nandana.
Thank you, ma'am.
Yeah. Danya, I want to see you, Danya. Very good. Thank you. Very nice. All right. Danya, so far you have not shared the pictures of your classwork even once, darling. Please share. I want to see your handwriting. I want to know how you work. Unmute, unmute. Unmuted.
Ma'am, my mom was in out of station, so I can't send it, ma'am.
Okay.
She was only sending the link only, ma'am.
Okay, so when can you share the pictures? You should have texted me, no? You should have texted me this reason.
In mom number only having your number, ma'am.
Oh, okay, okay, fine. So when can I see your classwork pictures?
Ma'am, tomorrow or day after tomorrow.
Okay, fine. Take your time. Okay,
ma'am.
okay.
Okay, ma'am.
All right, class, please tell me, have we finished all this? What should be subtracted from? Have we done all this?
Yes, ma'am. No, ma'am. This we don't.
No, I think we finished.
Yes, ma'am. We finished this, ma'am. Given as a homework, ma'am.
Correct. Okay,
Yes,
one
ma'am.
minute.
This
I'll
we
just show you the
completed.
questions.
Yes, ma'am.
See.
We completed this.
This is over, right?
Yes, ma'am. We have also discussed this.
Okay, the second one.
Ma'am, we have discussed, ma'am.
Okay, so then all this is over. Oh yeah,
Ma'am,
I think so. Yeah.
Ma'am, fifth one we have discussed in class itself, ma'am.
All right. So
This he
children,
gave us homework.
yeah. I think we discussed these answers in the class, and you remember, children, I had corrected one answer in the last class. This one. What is the negative of a negative rational number? The negative of a negative rational number is positive. Now, there was another answer, meaning the answer which was there earlier was different. So I framed a question for that. If that should be the answer, what should be the question? Okay, so I framed a question for that. Let me tell you now. So this we saw in the last class. We discussed all this in the last class, children.
Yes, ma'am.
Yeah. The presentation has changed. That's all. I just changed the presentation. Okay, now see here. What is the negative of a negative rational number? So let us take a negative rational number. For example, minus 5 by 6. 5 by 6 is a rational number because it is in the integer by integer form. 5 by 6 is a rational number and it is a negative rational number because it's minus 5 by 6. It's a negative rational number. Now, what is the negative of this negative rational number? The negative meaning the additive inverse. Negative meaning the additive inverse. This number minus 5 by 6 added to what will give you the answer as 0. So clearly the answer is 5 by 6. So this is a negative rational number. Its negative is positive. Is a positive rational number. Yes or no?
Yes, ma'am.
No, see, we are trying to understand using this example. Take up the rational number 5 by 6. Minus 5 by 6 is a negative rational. It's not the negative of a rational number. It's a negative, positive, negative rational number. Now, what is the negative of minus 5 by 6 is the negative rational number. What is the negative of this rational number? 1 second, children. I didn't enable the lobby. Okay, so 5 by 6 is a rational number. 5 by 6 is a rational number. Minus 5 by 6 is a negative rational number. The negative of this negative rational number is 5 by 6. Is 5 by 6. The negative of this one is 5 by 6. Why? Because minus 5 by 6 plus 5 by 6 is 0. So the answer to this question, what is the negative of a negative rational number? The negative of a negative rational number is positive, meaning the negative of minus 5 by 6 is plus 5 by 6, which is positive, That's the answer for the 7th one. I framed a question for the next one. See the question, what is the negative of the negative of a rational number? What is the negative of the negative of a rational number? So let us take the rational number 2 by 3. Let us take the rational number 2 by 3. Now, what is the negative of this rational number? What is the negative of this rational number? Minus 2 by 3. What is the negative of this one? 2 by 3. So the answer is the rational number itself. Because we have to find take a rational number, find its negative, and find the negative of that. Take a rational number, find its negative, and find the negative of this one. So the final answer is the rational number itself. The final answer is the rational number itself. That is what is this? What is the negative of the negative of a rational number? So take a rational number, find the negative of the rational number, and find the negative of this one. Whatever answer you got here, find the negative of that. See here, I'll show you here. Take a rational number. Find the negative of that rational number. Now you have an answer here. To that answer, find the negative again. See, negative of this answer. Take a rational number. Find the negative of that rational number, because negative of a rational number. So take a rational number and find the negative of that rational number. Now you have an answer here. You have some answer here. Now find the negative of this answer. See, a negative of this one. So we'll take different examples and see. Now supposing we take minus 7 by 8. Its negative is 7 by 8 and its negative is minus 7 by 8. If you take a positive 7 by 8, its negative is minus 7 by 8 and its negative is again 7 by 8. Minus 7 by 8. Its negative is 7 by 8 and this one's negative is minus 7 by 8. So you get the rational number itself. Negative of 7 by 8 minus 7 by 8. And the negative of this minus 7 by 8 is 7 by 8. So you get the rational number itself. The negative of a rational number is the rational number itself. So these are two different questions. What is the negative of a negative rational number? It's positive. What is the negative of the negative of a rational number? Is the rational number itself. Other answers we have discussed, right, children?
Yes, ma'am.
Please take down that extra question, that 8th one. Please take down the 8th one in your notebook.
Uncompleted.
Yeah. Done, children?
Yes, ma'am.
Okay. Yeah, we've seen these properties. These are the properties of multiplication of rational numbers. We've already discussed the properties. When we started this chapter, we discussed all the properties. But I want you to take a screenshot, leave some space. I want you to write this again. Take a screenshot, children, so you all know the closure property.
Took screenshot, ma'am.
Yeah, when you closure property, let's recall that is when you multiply, we are talking about the closure property of rational numbers. So when you take two rational numbers, when you take two rational numbers and find their product, the product is also, or I should say, when you take two rational numbers and multiply them, their product is also a rational number. So rational numbers are closed under multiplication. The product of two rational numbers is always a rational number. When you multiply two rational numbers, the answer or the product is always rational. So that means rational numbers are closed under multiplication. Commutative is, you'll have to take two rational numbers. When you multiply them in any order, the result will be the same. Associative property of rational numbers, associative property of multiplication of rational numbers. So when you multiply, here we should take a minimum of 3. Here we must take a minimum of 3. So when you multiply them, you group them in different orders and you multiply them, the answer will be the same in any case. You group them in different orders and find the result will be the same always. Multiplicative identity. Multiplicative identity. I hope all of you took a screenshot of this one.
Yes, ma'am. Took.
Yeah. So existence of multiplicative identity. Identity means you should get an identical answer, meaning like we have an additive inverse. Sorry, additive identity. What is the additive identity of rational numbers? 0 is called the additive identity of rational numbers. 0 is called the additive identity of rational numbers because any rational number plus 0 is the same answer. The same thing is the rational number itself. Rational number plus 0 is the rational number itself. So 0 is called the additive identity because you're getting the same identical answer. The answer is identical to the rational number itself. Minus 1 by 7. When you add 0 to this, the answer is minus 1 by 7 itself. Or to 0 if you add minus 2 by 3. To 0 if you add minus 2 by 3, you will get the same answer, minus 2 by 3. Minus 2 by 3. 0 added to any rational number or any rational number added to 0. 0 added to a rational number or a rational number added to 0 will give you the rational number itself as the answer. The answer will be the rational number itself. So 0 is called the additive identity. Additive identity. No, this is multiplicative identity. What you see now on your screen. 0 is the additive for addition. Additive identity. What's the additive inverse? Additive inverse. What is the additive inverse of minus 3 by 5?
Ma'am, plus 3 by 5, ma'am.
Plus 3 by 5. Because when you add these two, the answer is 0. What is the additive inverse? What is the other term for additive inverse?
Negative of a rational number, ma'am.
Negative of a rational number. Additive inverse is also called the negative of a rational number. What is the negative of -5?
+5, ma'am.
+5. The negative of -5 is +5 because -5 plus 5 is 0. What is the negative of 7?
-7, ma'am.
-7 because 7 plus -7 is 0. Additive inverse is also called the negative of a rational number. Negative meaning take the opposite sign. Negative of a rational number, write the same rational number with the opposite sign. Negative of -2/3, you should write the rational number 2/3 with the opposite sign. So minus will become plus, so plus 2/3. Take the absolute value. Take the absolute value or this numerical value and fix the opposite sign. So multiplicative identity. So now -3/7 multiplied by what will give the same answer. -3/7. -3/7 multiplied by what will give you the same answer because multiplicative identity, identical answer, same answer I want. What should I multiply then? -3/7 into?
1, ma'am. 1 by 1.
Into 1. Okay, 1 by 1, which is nothing but 1. So 1 is called the multiplicative identity of rational numbers. For rationals means rational numbers. For rationals meaning for rational numbers. 1 is called the multiplicative identity for rational numbers or for rationals. Because if any rational number a by b is multiplied by 1 or 1 is multiplied by any rational number, the answer is the rational number itself. A rational number a by b multiplied by 1 or 1 multiplied by a rational number a by b. In both the cases, the answer is a by b itself. Identical answer. So 1 is called the multiplicative identity. A by b into 1 is the same as 1 into a by b. And the result is a by b. Okay. Now the next one is.
Ma'am, it signifies that the multiplication is commutative, ma'am.
Yeah. Yes. Multiplication is commutative. Correct. Multiplication is commutative. The existence of multiplicative inverse. Multiplicative inverse. Additive inverse means negative of a rational number. Multiplicative inverse means the reciprocal of a rational number. Reciprocal, we know. See, maybe multiplicative inverse you might take some time to process the meaning, but when we say reciprocal, you immediately understand because you're more familiar with this term reciprocal. Okay. So multiplicative inverse. So here additive inverse means rational number plus what will give 0. Here it is rational number into what will give 1. For additive inverse, it is rational number plus additive, no, so we should add given rational number plus what, the sum will be 0. Here for multiplicative inverse, this is additive inverse. For multiplicative inverse, it is rational number into, it's not plus, into, because multiplicative inverse. So into what rational number will give the product as 1. So for this rational number, this is the reciprocal. For this rational number, this is the reciprocal. Like we say, for this rational number, this is the negative. And for this rational number, this is the negative. Okay, so that means when you say -7/8, -7/8, that is when you take a rational number, when you take this rational number -7/8, multiplied by what will give you the result as 1. So you must take 7/8 should be written 8/7. And you want a positive 1. So we should write that sign minus. Then only minus into minus plus. 7 by 8 is 8 by 7. So what happens? It's minus 7 into minus 8 by 8 into 7. Multiply the numerators, multiply the denominators. Multiply the numerator. For multiplication, we don't take LCM. Addition and subtraction LCM. Multiplication, we don't take LCM. Multiply the numerators, multiply the denominators. So like this, minus 7 into minus 8. You can put minus 8 in a bracket also. It's okay if you write, but you can just put it in a bracket. So now what happens? 7 and 7 cancels, 8 and 8 cancels, and it's minus, only minus, that means minus 1. Only minus or minus 1. Minus 1 into minus 1 is plus 1. That means you must write the same sign. Just turn the, write the rational number upside down. Turn it, that's all. For additive inverse, you must change the sign. For additive inverse, you must change the sign. You should not turn the rational number. For additive inverse, we should not turn the rational number. You should just change the sign. For multiplicative inverse, don't change the sign. Turn the rational number. Let's see it again. Now, supposing we have to write the, additive inverse of 3 by 2. Okay, 3 by 2. The additive inverse of 3 by 2. Don't turn the rational number. Let it be 3 by 2. But just change the sign. Plus becomes minus. And we know that the sum is 0. So here change the signs. Don't turn the rational number. But if you have to write for 3 by 2, if you have to write the multiplicative inverse, turn the rational number. But don't change the sign. See, either you should turn the rational number or change the sign. For additive inverse, change the sign. For multiplicative inverse, don't change the sign. Turn the rational number. So here we change the sign. We don't turn the rational number. Here we turn the rational number. We don't change the sign. Plus is plus only. So there are two things: changing the signs, turning the rational number. So here we just, here in this case, additive inverse, we only change the rational, we only change the sign. We write 3 by 2 as it is. We don't turn this. Here we write the sign as it is and turn the rational number. 3 by 2 becomes 2 by 3. And the product is, how do you multiply? 3 into 2 by 2 into 3. So they'll get cancelled and the answer is 1. So the reciprocal of 3 by 2 is 2 by 3. That is the multiplicative inverse of 3 by 2 is 2 by 3. And the multiplicative inverse of 2 by 3 is 3 by 2. One is the reciprocal of the other. You can read it both the ways. 3 by 2 is the reciprocal of 2 by 3. 2 by 3 is the reciprocal of 3 by 2. Just a minute, children. Yes, children. So you can see it here. A by B into B by A is the same as B by A into A by B. In both the cases, the product is 1. A by B into B by A. That is, if the rational number is A by B, its reciprocal is B by A. If the rational number is B by A, its reciprocal is A by B. The product of a rational number and its reciprocal. The product of a rational number and its reciprocal is 1. If A by B is a rational number, its reciprocal is B by A. The product is 1. If B by A is a rational number, its reciprocal is A by B and the product is 1. So these two written together, this one is equal to this one is equal to 1. Both are equal to 1, no? So we just write it. in a continuous equality. In a continuous equality like this, this is equal to this is equal to 1. For both, the answer is 1. Okay, so that's about, additive identity, multiplicative identity, additive inverse, multiplicative inverse. What is the other term for, only for, inverse we have another term. Identity is the same. Additive identity, multiplicative identity. We don't have another term for them. But for inverse we have additive inverse is negative of a rational number. Multiplicative inverse is reciprocal of a rational number. For inverses, we have another term. Additive inverse, reciprocal. Multiplicative inverse, additive inverse, negative. Multiplicative inverse, reciprocal. Now it's time for you to answer questions. So, Bhavishya, what is the Bhavishya? What's the what is the additive inverse of minus 3 by 11?
Ma'am, 3 by 11, ma'am.
3 by 11. Why? Because?
Ma'am, because you have gave that additive inverse, ma'am. We should not change the numbers.
Correct. Now, what is the, what will happen? What should you perform and what will be the result?
Ma'am, we should only change the signs, ma'am. So only the result is 3 by 11, ma'am.
Okay, now the sum of these two will always be the sum of a rational number and its inverse is always?
Same, ma'am.
Not same. 0, right?
Okay.
Yeah, okay. So fine. What is the additive inverse of 2 by 7?
Ma'am, minus 2 by 7.
Minus 2 by 7. Because 2 by 7 plus minus 2 by 7 is 0. Correct?
Yes, ma'am.
Okay. Danya? What is the additive identity of rational numbers? That is, I have a rational number minus 11 by 13. I want to get the same answer. Then what should I add?
Ma'am, 1.
1, no? What is 4 plus 1? Is it 4?
Ma'am, 5.
Yeah. But 4 plus what will give me 4 itself?
In 0.
0. So what is the answer here?
0.
0. 0. I have a rational number minus 11 by 13. I want to add something to it, but I want to get the same answer.
Ma'am, 0.
Identical answer.
Ma'am, 0.
Add 0. So 0 is called the additive identity of rational numbers. Now talking about Swati, multiplicative identity. So I have a rational number 101 by 102 minus 101 by 102. I want to multiply this by something, but I want to get the same answer. So what is the number here?
Minus 1, ma'am.
Minus 1?
I mean plus 1, ma'am.
1, because I want to get the same answer, minus 101 by 102. 1. So what is 1? 1 is called the multiplicative. Multiplicative because when you multiply, multiplicative identity of rational numbers. 1 is called the multiplicative identity of rational numbers because any rational number multiplied by 1 will give the same rational number. Same thing, identical answer. Now what's the reciprocal of minus 13 by 20?
Minus 20 by 13, ma'am.
Minus
20 by 13, ma'am.
Yeah, so we say that the reciprocal of minus or the multiplicative inverse of minus 13 by 20 is minus 20 by 13 because when we multiply the given rational number and its inverse, multiplicative inverse, The product, so no, they'll get cancelled like this. The product is 1. Minus 1 into minus 1 is 1. Plus 1. All right, children. So nothing to get confused in these things. Let's work one of the 4 you see here. Verify each of the following. What property is illustrated here?
Ma'am, commutative property of multiplication, ma'am.
Of rational numbers. Very good. Commutative property of multiplication of rational numbers. So you take 2 rational numbers and multiply them, in any order, A into B or B into A. The answer will be the same. So work the third one, children. Let's work the third one. Let us work the third one. This one. So what is the LHS? LHS is minus 12 by 5 into 7 by minus 36. So whenever we have to multiply rational numbers, we multiply the numerators, we multiply the denominators. No LCM here. We multiply the numerators, we multiply the denominators. Then you can simplify. 12 ones are 12 threes are 36. So you get, and your minus and minus will get cancelled. So we have 7 by 15. And when you take the RHS, which is 7 by minus 36 into minus 12 by 5, we have to multiply these 2 rational numbers. We multiply the numerators and we multiply the denominators. No LCM. Again, you can simplify. 12 ones are 12 threes are. And you can see minus and minus gets cancelled. So 7 by 3 5s are 15. So you can write anything, you can say LHS is equal to RHS, hence verified. LHS is equal to RHS, hence verified. Or you can write, therefore, you can just put a therefore and write the question itself, the given statement itself. Therefore, this one. What is the given statement? So when we multiply rational numbers, we multiply the numerators and we multiply the denominators. And also, what is the simplification? We are dividing. Okay, finish this, children. Let me say something. We say simplify. Done? All right. Others?
No, ma'am.
Good evening, Harshita.
Ma'am, I'm not able to see the screen, ma'am.
Okay.
Ma'am,
Yeah. Now, Danya?
ma'am, now only I'm visible, ma'am.
No, that's what, when it happens, you just have to leave the meeting and join again. So do that quickly.
Ma'am,
Sometimes.
it's visible, ma'am, now.
Yeah, it's visible. Yeah. Okay. Finish writing, children? All of you?
Yes, ma'am, done the 4 sums.
Okay. Let me show you the answer in the slide which I've prepared. So you can see it here. By using the bracket is optional, children, your choice. If you want, you can use a bracket. So when you think there are 2 operations, like 5, multiplication is a mathematical operation. Again, we have another mathematical operation like minus. It's a negative 36, but we have 2 operations. So you can enclose this in a bracket saying that it's negative 36. But again, you don't, you will not lose marks if you don't use a bracket also. Supposing you don't use this bracket, it's okay. It's okay. Okay. If you want to be safe, use the bracket. So I wanted to be safe, so I use the bracket. And that too, when to use a bracket? That is when, if there are, like 2 mathematical operations together like this. One after the other like this. See here, I did not use a bracket because minus 36. That's okay. I hope you understand. Here, because there's multiplication and a negative sign, I used a bracket here. Here you don't have to use. Okay, children, exactly what I wrote there. You can see, take up the LHS, multiply the numerators, multiply the denominators. 12 ones are, 12 threes are. Minus and minus gets cancelled. 1 into 7 is 7, by 5 threes are 15. Same thing in the RHS. So now what is the simplification? That is, we are dividing both the numerator and denominator by 12. See, you don't have to write all this. You don't have to write all this. We are dividing both the numerator and denominator by 12. We are dividing this numerator and this denominator by 12. So it's like this, minus 12 into 7. We're dividing the numerator by 12 and we are dividing the denominator also by 12. We're dividing this also by 12. We don't have to show these steps. Let me write it again. See, this is the numerator. You're dividing by 12. And this is the denominator. You're dividing this one also by 12. You must divide both the numerator and the denominator by the same number, not 0, anything other than 0. So now what happens? This 12 and 12 gets cancelled. This 12 ones are and 12 threes are. That's what you see here. In the next step. And minus and for minus cancelling out, we divide by minus 1 in the next step. Or you can I can straight away say divide by minus 12. Divide by minus 12. So then minus 12 and minus 12 gets cancelled. And then this minus and minus goes. 12 ones are 12 threes are. So 7 by 15. I hope you can see that. 7 by 5 threes are 15.
Ma'am, is that the same like cancelling minus 12 and minus 36?
Yeah, it's the same thing.
Yes, ma'am.
That's what is happening. You're dividing both the numerator and the denominator by the same number.
Yes, ma'am.
Yeah. All right, children. So this is about, I hope all of us finished.
Yes, ma'am, done.
Now let's try the second one here. What's the property illustrated there?
Ma'am, associative property of multiplication of rational number.
Yeah, associative, because we have 3 numbers there. Associative property of multiplication of rational numbers. Yes. So we need to take up the LHS. Minus 13 by 24 into minus 12 by 5 into 35 by 36. This is the LHS. Take up the LHS. Then after that, what do? You need to first simplify this bracket. Please listen to me. You might know it, children, but still listen to me. You need to first simplify this bracket. So write this minus 13 by 24 as it is. This multiplication sign as it is. Now this bracket has to be simplified. How? Multiply the numerators, multiply the denominators. Now you can simplify. 5 ones are, 5 sevens are, 12. Within this you should simplify. Within this one. So 12 ones are, 12 threes are, 7s are. So it is minus 13 by 24. This is not disturbed. Into what is here, minus 7 over 3. I hope I'm right. Am I right?
Yes, ma'am, you are.
Yeah, now we simplified this bracket and we have got minus 7 by 3. Now multiply this with minus 13 by 4. So now how do you multiply two rational numbers? We multiply the numerators, we multiply the denominators. And again simplify if it is possible. If it's not possible, simply multiply. 13 7s are 91 by 24 3s are, I think it is 72. I hope my calculation is right. Please check But this is the procedure. All right.
Yes, ma'am.
All right, children. Now, what do we do with the RHS? Just do what the bracket says. Let me finish the RHS and then you can start writing. So what is in the RHS? Write the RHS as it is first. So minus 13 by 24 into minus 12 by 5. Write the RHS as it is. Then what to do first? This bracket must be simplified. I'm sure some of us are writing. Let me check now. See that Bhavishya's head came up. Bhavishya, you're working, right?
No, ma'am.
No,
No, ma'am.
Okay. What about Nandana? Are you writing? See that? What is this, Nandana? You should check if I'm teaching correctly. No. Yeah. See what I'm saying? Yeah. So this bracket must be simplified first. So how do we simplify the bracket? It's a product of two rational numbers. So we multiply the numerators, write it like this. We multiply the numerators and we multiply the denominators. Yeah, I must say Swati was the only person who was listening to me. I don't know about Bhavishya. But then she showed her book. She's not writing. I could see only Swati staring at the screen. Please listen when I'm saying, children. Like you all, even Swati knows the answer, but still she listens when I say. All of you, please listen when I'm saying something, when I'm explaining. So in the bracket, children, we have two rational numbers. In the bracket, we have two rational numbers which have to be multiplied. So multiply the numerators, multiply the denominators, and write it like this. Write this one as it is, 35 by 36 as it is. Now here we need to simplify. You can 12 ones are 12 twos are. So it is minus 13 into, now multiply the numerators. Minus 13 into minus 1 is plus 13. Children, we know that, right? Minus 13 into minus 1 is plus 13.
Yes, ma'am.
Multiply 13 ones are 13, minus into minus plus. Okay, let me check with some questions after this one. And then 2 5s are 10. Now into 30. So we have simplified this bracket. The answer for this bracket is 13 by 10. Now into 35 by 36. Now again, it's a product of two rational numbers. Multiply the numerators, multiply the denominators. So 5 2s are 10, 5 7s are 35. Now 13 into 7 is 91 and 2 into 36 is 72. So we get the same answer, 91 by 72. LHS is equal to RHS, hence verified. All right, children, I'll show you the answer slide. You don't have to copy from here. Now, what is minus 4, minus 5, minus 6? What's the answer? Swati, what's the answer?
Ma'am, are you saying to multiply?
No, that's all. Just the heading is evaluate. Evaluate. That's all. Minus 4, minus 5, minus 6. Yeah. Evaluate meaning find the value of. Evaluate meaning find the value of. What's the value of this one? This is called an expression. This is an expression. What's the value of this expression?
Plus 6.
Plus 6, huh?
Yes, ma'am.
How?
Ma'am, first I changed the additive inverse, ma'am, like minus 4 plus 5 plus 6, ma'am, and minus 4 plus 11, ma'am, and then I got plus 6.
Okay, 1 minute. So you wrote it as minus 4 plus minus 5, is it? Plus
yes, ma'am.
Minus 6. This is what you wrote first. Okay, then?
Ma'am, and then I changed it.
Yeah, tell me what you write after that.
Ma'am, then I added minus 5 plus minus 6, ma'am, to
What
get
did you
minus 11.
Minus 11. Okay, so plus minus 11. Okay, then?
Ma'am, then minus 4 plus 11.
It's not plus 11, it's minus 11.
Yes, ma'am.
How much is it?
So we'll be getting minus 15.
Minus 15. It's minus 15.
Ma'am, but I didn't do like this, ma'am. Like minus 4 plus 5 plus 6 I did it, ma'am.
Minus 4 plus 5 plus 6. So you're
Yes.
changing the question itself?
Ma'am, no, ma'am. I just changed minus 5 and minus 6 into its additive. I like inverse, ma'am.
No. No, you're not changing it. You're changing it, that's all. These two expressions are not the same. The expression given and the expression you have changed it to is no, they're not the same. This is all you should do. If you want to change, this is what you should be doing. If you want to express it as a sum, if you want to use that concept of additive inverse, this is what you should do. Write minus 4, use the connector plus, and then this minus 5 inside. Then use the connector plus this minus 6 inside the bracket.
I thought you were asking the difference, ma'am.
No, I didn't say anything. I said evaluate. I didn't say anything. That means do as directed. Do as directed. Whatever the expression, whatever the expression means to you. So evaluate meaning no, the headings does not say add, subtract, multiply, divide. The heading does not say anything. When the heading is evaluate, that means we should find the value of. Find the value of. So you find the value. Whatever you understand out of the expression, find the value. So it's minus 4, minus 5, minus 6. There is no multiplication sign. There is no division. It's simply there is this number minus 4, there's this number minus 5, there's this number minus 6. All of them have the same sign. So you can do two at a time. Same signs, minus 4, minus 5. Same signs. So you should add. You will get 9 and put the same sign. Then write this minus 6. Now again same signs, add and put the same sign. Last time when somebody submitted the classwork, you have not written this correctly. Write this, children. Same signs. I'll write the question again. Same signs you must add and put the same sign. Put the same sign. When you have different signs, you need to subtract and put the sign of the greater number. Put the sign of the greater number. Sign of the greater number. Somebody had not written this. Only this I saw in your book. One of you who had written only this one. Did not write this. Different signs, subtract and put the sign of the greater number.
Ma'am, can you give me another sum like this?
Yeah, sure. Yeah. When you're multiplying or dividing, what do you do? What do you do when you multiply or divide? For multiplication and division, rules are the same. Same multiplication and division. So supposing we have plus 5 multiplied by plus 3. Just multiply the numbers first. Multiply the numbers 15 and minus into minus is plus. Plus into plus is plus. Multiply, because it's multiplication, you have to multiply. 5 3s are 15. And the signs Plus into plus is plus. Now supposing we have minus 5 into minus 3. First multiply 5 and 3, 15. Then minus into minus plus. So that means same signs, put a plus sign. Same signs, plus, plus, when you're multiplying, plus into plus, plus. Minus into minus is also plus. Same signs, put a plus sign. You have to multiply 5 and 3. See, when it's multiplication, you have to multiply. There is nothing, meaning there's an addition or subtraction does not come here at all. When it is plus 5 into plus 3, that means it's multiplication. Multiply 5 and 3, 15. Now the signs, plus into plus. That is, you're multiplying the signs and the numbers. When you multiply the signs, plus into plus, plus. The numbers 5 and 3, 15. In the next one, when you multiply the signs, minus into minus, plus. 5 and 3, 15. When you have different signs like this, when you have like minus 5 and say a positive 3, it is multiplication. So multiply 5 3s are 15. Then minus into plus, minus. If it is 5 into minus 3, that is a plus 5 and a minus 3, it's multiplication. So we have to multiply. You cannot add or subtract here. It's multiplication. So 5 3s are 15. Plus into minus. So when you're multiplying, you multiply the numbers, you multiply the signs. When you multiply the signs, same signs, put a plus sign. Different signs, put a minus sign. And multiply the numbers. Is it okay, children?
Yes, ma'am, understood.
Okay. So 1 minute. So let me check with addition, subtraction, multiplication. We'll come to division later. See here. Let's just practice what we have understood instead of telling you the rules of division now. It's the same as multiplication. It's as simple as that. Now evaluate. So I'm not saying add, subtract, multiply or divide. I'm just saying evaluate. You find the value. Minus 9 plus 8 minus 20 plus 11 is equal to. You can just try, children. You can just try.
I've got the answer.
What's your answer?
Minus 11, ma'am.
Minus 11, huh?
Yes, ma'am. 1 second, I'll recheck it.
Yeah. Yes, somebody else be quick to tell the answer. Swati is still checking. What's the answer? Harshita, can you turn on your video, Harshita? Danya?
Ma'am.
Yeah.
Ma'am, for me, minus 10 is coming, ma'am.
10, yes, ma'am. I recheck. Minus 10, ma'am.
Who said first minus 10?
Ma'am, Bhavishya.
Bhavishya. Okay. Yeah, okay.
Ma'am,
Yeah.
ma'am, my camera's not working, ma'am.
Okay.
So
Harshita?
I leave the meeting and come in.
Okay, okay, okay. Harshita, adjust the lid of your laptop, or if you're using a mobile phone, adjust it. Yeah, using a laptop. Yeah. Did you join the class on time, Harshita?
No, ma'am, I joined a little late, ma'am.
Okay, fine.
Ma'am, I did a silly mistake, ma'am. Minus
Yeah.
21 plus 11, I did it 11, ma'am. Minus 11.
Yeah. No, that's what 21 and 11. No, so suddenly you feel it's 11. Yeah, that happens. So we have to be careful. So
Yes.
there's nothing like a procedure, now in 8th standard, if it was, 6th or 7th standard, then, we say collect the negative numbers, the positive numbers, the negative. So you can do that. Anything is fine. You can do it as it is also. See, children, if you're in 6th or 7th also is fine. 6th standard, when you're introduced to integers, then, we say children to collect the negative numbers, the positive numbers, and do them separately like that in 2-3 steps. You can do it in one go. What is -9 plus 8? Different signs.
Minus 1, ma'am.
See, children, one thing you should understand is there is no multiplication or division here. Yes or no? Is there any multiplication or division here?
No, ma'am.
No, there's only addition, subtraction. Now, whether you have to add or subtract also, we don't know. You should use the signs. If the numbers have the same signs, you should add. If the numbers have different signs, you should subtract. So now, -9, again, here we don't know. See here, -9 plus 8 does not mean you should add. They have different signs. -9 plus 8, different signs. So subtract 1 and put the sign of the greater number, -1. So this will give you -1. This is -1. Now -1 and -20, same signs. So add and put the same sign. Next, now we finished till here. Next, -21 and +11. Different signs, -21 +11. Different signs, subtract. Put the sign of the greater number, -10.
Ma'am?
Yeah?
Ma'am, I have done in another step, ma'am.
Yeah. No, here, it's okay. Yes, Bhavisha, you can read and you can tell your steps.
Ma'am, first I have taken that minus numbers, ma'am. -9 plus
Yeah,
-20.
like that. I'll do
Yes,
that.
ma'am.
Just tell me the question again.
-9 plus 8 -20 plus 11, ma'am.
Okay, so what Babushi has done is she's taken -11, -20. Children, you should not change the signs. You're not transposing. You're just, it's an expression. It's not an equation at all. It's an expression. So you cannot change the signs. -20 will not become +20. It's an expression. So you're just grouping -9, -20, then +8, +11. Now here same signs. So you should add and put the same sign. Here again same signs. +8, +11, same signs. Add and put the same sign. Now different.
-10.
Now these two numbers have different signs. These two numbers. So subtract 10 and put the sign of the greater number. So -10. Yes or no, children?
Yes, ma'am. -10.
Yeah, -10. Same signs, add. Different signs, subtract. Same signs, add and put the same sign. Different signs, subtract and put the sign of the greater number. Okay. So maybe evaluate -3. What's the answer for this? Now what is -3 and -7 connected with? Which operation?
Multiplication, ma'am.
It's multiplication. It's multiplication. So 3 sevens are 21. Minus into minus plus.
I'm 25, ma'am.
Yeah, see, when it's multiplication, multiply the signs, multiply the numbers. Multiply the signs, minus into minus plus. Numbers 3 sevens are 21. So we are done with this. Then this +4. Now there is no multiplication. +21 +4. No multiplication. Say we have two numbers with the same signs. So add and put the same sign plus, or it's just 25.
Ma'am, while reading, we will say as -3 of -7, ma'am.
Yeah, minus 3 of minus 7 plus 4. Yes. All it should do. Including the slide. Now, I think, should we do this one? Should we do this one or we finished? I forgot.
This one only we have completed, ma'am. Minus 91 by 72, ma'am.
Oh, we finished that. Huh? Okay, we finished that. Okay, fine. Let me show you the. Okay, I need to show you the answer slide. Yeah. You have not still completed this, right?
Yes, ma'am.
Yeah. Children, yes, write down now.
Ma'am, only the second one.
Yeah, only the second one, children. And all the others are reserved for tests. Suddenly, we'll come back here to this one and, we'll do. On different days, we'll solve them.
Yes, ma'am.
Yeah. Yeah, Nandana will complete because Nandana never listens to anything, no? She'll start writing.
No, ma'am, not like that.
Fine. We'll complete it. Please wait. See, children, I have to type all this and prepare the slides. I might go wrong in typing somewhere. I might say 3 and type 5. So please check. These are not, got from the internet anywhere. I prepare these slides. So while typing, I can go wrong. So if you find any mistake, you can let me know. The concept will be correct. You just check if there's any calculation mistake or something. So which means you should not blindly copy. You must know what you're writing. So children, now don't wonder how suddenly after this she's writing minus 7 by 3. I can't show that cancelling and all that. So 12 ones are 12 threes are 5 ones are 5 sevens are. You should show all this. So now minus 1 into 7 is minus 7 and 1 into 3 is 3. Simplification. So that I cannot show while typing. So how suddenly from here we got this one is because we simplify 5 sevens are. Here also. Oh, suddenly like this because 12 ones are 12 twos are.
Yes, ma'am.
Yeah. You must show the cancelling and all that. That alone will not be there in the presentation.
Done, ma'am.
All right, all of you.
Yes, ma'am.
So children, see the final answer, it's left to you. You can say we may, write LHS is equal to, not that you should present it like this. You should write the question again. See, because in the exam, you want to save time. You want to write faster. You can, every minute matters in the exam. So you can quickly write LHS is equal to RHS, hence verified. Hence verified. This you can finish it faster. But if you have to write this question again, you'll have to carefully copy the same thing, without making mistake. So you can also write this. After working the LHS and RHS, you can write LHS is equal to RHS, hence verified. Quickly you can write this. Anyways, you can either write therefore the given question, meaning the given statement. You can write therefore the given statement is correct. This one is equal to this one. But this you should carefully copy the question. If you think You want to finish it fast, you can just say LHS is equal to RHS, hence verified. So you can write that very quickly, verified. All right. So that's about verifying the associative property of multiplication of rational numbers. We're dealing with rational numbers, it's multiplication and it's associative because three rational numbers. You can see we have taken three rational numbers. The three rational numbers are minus 13 by 4, or sorry, minus 13 by 24, minus 12 by 5, 35 by 36. You can see the same thing here, 35 by 36, minus 12 by 5, minus 13 by 24. Just that they are grouped in different ways. Here the last two is grouped, here the first two is grouped. But the answer is the same in both the cases. That is why we say rational numbers are commutative under addition, multiplication. Oh my God. That is why we say rational numbers are associative under multiplication. Rational numbers are associative under multiplication. Yes. Harshita, can you complete the first one?
Ma'am, yes, ma'am.
Yeah.
Minus 23 by 17 into 18 by 35 is equal to 18 by 25 into minus 23 by 17.
Very good. So minus 23 by 17. What property did you use to complete the statement?
Associative, ma'am.
Associative means three rational numbers. How many rational numbers are here?
No, 2, ma'am.
2. So that means it is
Commutative.
Commutative. Commutative.
Okay.
Commutative. So some teachers say commutative. Well, I say commutative.
Okay, ma'am.
Yeah, commutative property. Now, is it of addition or multiplication, Harshita?
Ma'am, ma'am, it is multiplication, ma'am.
So we say it is commutative property of multiplication, and the numbers are rational numbers, right?
Yes, ma'am.
So we say commutative property. Commutative because there are two rational numbers under consideration. There are only two, minus 23 by 17 and 18 by 35. So commutative because two rational numbers. Multiplication because it's multiplication, and rational numbers. So you should use these three terms and frame the property. Commutative property of multiplication of rational numbers. All right.
Okay, ma'am.
Into your mind. Thank you. Yeah. So children, we have used the commutative property to complete the statement. So we fill this blank using some property, and that property is commutative property of multiplication of rational numbers. Yeah. Whom should I ask? Danya. The second one, Danya. Quickly. Danya, the second answer. Fast.
Ma'am, 1 minute, ma'am, I'm solving.
No, there's nothing to solve, darling. Just look at it and you can say. Don't solve.
Ma'am, minus 38.
Minus 38. Very good. Minus 38. What property is this? Which property did you use to complete this?
Ma'am, commutative.
Commutative property of?
Commutative property of.
Addition or multiplication?
Ma'am, multiplication.
Of?
What, ma'am?
Of natural numbers or integers?
Ma'am, integer.
No. Minus 7 by 19 is not an integer.
Ma'am, how it's possible, ma'am?
Why? What is not possible?
Ma'am, it is a rational number, ma'am. P by Q form.
Sorry? Not integers. How? Then minus...
Okay, ma'am, now I can understand.
Yeah, no, tell me. Commutative property of multiplication of? I'll give you the options. Natural numbers, whole numbers, integers, rational numbers.
Ma'am, natural numbers.
No,
Ma'am, rational.
rational numbers. Rational.
What, ma'am?
Rational numbers. Correct.
Yes. Yes, ma'am.
Okay. So, Nandana, third one.
Third one is 15 by 7, ma'am. It is associative property of multiplication in rational numbers, ma'am.
Very good. So that is the property which you have used to complete the statement.
Yes, ma'am.
That's the property you have used to complete this statement. Very good. So now Swati, Bhavishya remaining. Let me ask Bhavishya, what's the answer for the fourth one?
Ma'am, for fourth one, minus 12 by, 25 by minus 16, ma'am.
Property?
Ma'am, this is a associative property on multiplication on rational numbers, ma'am.
Yeah, of, not on. Of multiplication of rational numbers.
Okay, ma'am.
Very good. Now we don't have to write that property, children. We are just discussing the property. You just have to fill in the blank. You just have to fill in the blank. You don't have to write we are discussing the property with the help of which we completed the answer. Yes, children, write on fast. You can see the answer in the blank. As you write, see if I've answered it correctly. Done, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Over to the next one. So this you can take a screenshot and finish it, children. You can see the questions above. It's all about the reciprocal of a rational number. And you know it very well. Leave some place to this. Only then you will complete it. Or just write the heading. Find the multiplicative inverse of. Write the heading and maybe you can write the first question and leave some space. Then when you see that empty space, you know you have to fill it.
Yes, ma'am. Took screenshot.
Yeah. So we should write the multiplicative inverse of 0 by 2 does not is equal to. By mistake. Does not exist. That's all. No equal to sign there.
Ma'am, because when we divide it, we do not get 1.
Because no, that's because there is no number like that. 2 by 0 is not defined. The reciprocal is 2 by 0, which is not defined.
Yes, ma'am. Ma'am, I thought 0 by 2 is 0, ma'am. That is not equal to 1.
Yeah, multiplicative inverse means 0 multiplied by what can give us 1.
Reciprocal of it, ma'am.
Yeah, the reciprocal of it, which does not exist, because 0 is 0 by 1, 0 by 2, 0 by 3, it is 0. But the reciprocal is 1 by 0, which does not exist at all. It's not defined.
ma'am.
Yeah. The multiplicative inverse of 0 by 2 does not exist. Does not exist or is not defined. You can say does not exist. Or you can say the multiplicative inverse of 0 by 2 is not defined. Is not defined. It's not defined. Anything you can write. Now, you might think this is exponents, but we have a symbol or we have a symbolic way of writing the reciprocal of. So when we write please listen to this. Now the value of 5 by 8 to the power 1 is 5 by 8 itself. The value of 5 by 8 to the power minus 1 is nothing but the reciprocal of the number, which is 8 by 5. So the symbolic way, when you raise a rational number to the power minus 1, you are expected to write the reciprocal of that rational number in the bracket. See, there is a bracket. There is some number, there's some rational number in the bracket raised to the power minus 1. When the power is minus 1, it means reciprocal. Write the reciprocal. That is, how do you read this? See here, I'll read this for you. The reciprocal of 5 by 8 is, that's what you should write. See here, the reciprocal, I'm just reading it like that for you so that you understand, okay? See here, the reciprocal of minus 4 by 9 is, the power minus 1 indicates the reciprocal. You should write the reciprocal of minus 4 by 9. So whenever you see the power, now we'll learn more about exponents in the chapter exponents. Now we are not learning exponents. We're just trying to understand what the power minus 1 means. When a rational number is raised to the power minus 1, you are expected to write its inverse or the reciprocal. So which means you can see the answers here. Please write down now. You can see here. You should not write the reciprocal of and all that. This one, the value of this one is, it's reciprocal 8 by 5. The value of this is minus 9 by 4. The value of this one is minus 1 by 7. And this one is minus 3. Yes, please write down this, children. First and second, I just want to, the second one also, I just want you to write it like this. Please write from what I am writing now, children. 5 by 8 to the power minus 1 is 8 by 5, the reciprocal. The second one, minus 4 by 9 to the power minus 1. We'll write it as 9 by minus 4. It's the same as minus 9 by 4. It's the same thing, but we'll put it's minus 4. So we'll write it as 9 by minus 4. You can say it's the same as minus 9 by 4. Any answer. Supposing you have to select the correct option and you find this option, select it. Don't say, I didn't find this option. Both are the same. The third one, minus 7 the whole power minus 1 is nothing but minus 7 by 1, right? The whole power minus 1, which is 1 by minus 7. Or you can also write as minus 1 by 7. Whatever. Minus 7 means minus 7 by 1. I am writing it with the power minus 1 only. I have not written the reciprocal. I am writing it with the same power minus 1. I am just writing minus 7 as minus 7 by 1. I am just writing minus 7 as minus 7 by 1. The whole power minus 1, which means I have written the question only, is equal to 1 by minus 7, reciprocal. Or you can also write it as minus 1 by 7. 1 by minus 3 to the power minus 1 is equal to the reciprocal. Reciprocal of this one is minus 3. 1 by minus 3 is minus 3 by 1. Okay, you can write minus 3 by 1, which is nothing but minus 3. Please write what I have written, children.
Completed, ma'am.
All right.
I'm done, ma'am.
Yeah. Children, don't get confused. I've written the question only again. I've written minus 7 as minus 7 by 1. I've written the question only. See here, to the power minus 1. To the power minus 1 is a question only. Now here is the answer. Reciprocal of this, 1 by minus 7. Or you can write minus 1 by 7. Both are correct. Right. So we have understood multiplicative identity, multiplicative inverse, the commutative and associative properties of multiplication of rational numbers. So the next one is the distributivity or the distributive property of multiplication over addition for rational numbers. We also have the distributive property of multiplication over subtraction for rational numbers. Let me read it slowly. Distributivity meaning distributive property. Distributivity meaning distributive property of multiplication. This is the operations. We have two operations here. Distributive property of multiplication over addition for rational numbers. And we also have the distributive property of multiplication over subtraction for rational numbers. Now, how does that work? When you have three rational numbers A, B, and C, A into B plus C. Now we are distributing this is equal to. Now you'll ask me now, how do you know this is true? We'll be verifying these results. You will see that these results, when you work the LHS and work the RHS, you will see that the result is the same in the LHS and RHS. So this you're learning as a property now, which you will be verifying. Now you will have some questions where you will verify and you will believe that, yeah, this result is true. Like you believed earlier, you know, the commutative property, associative property, we verified, right? And then we believe, yes, we are getting the same answer in the LHS and RHS. Here also, now I'm just telling you, so you will have to nod your head, okay, fine. But now when we apply this, I think see here, verify. So when you verify, see here, this is the LHS, this is the RHS. When you verify, you will get whatever you get here, you will get the same answer here. So that means it is true. That means the property is true. Distributive property or the distributivity or distributive property of multiplication over addition, distributivity of multiplication over subtraction of for rational numbers, or for rational numbers. So now when you have three rational numbers A, B, and C, you will see that A into B plus C is equal to A into B plus A into C. Let me show you again. When you have three rational numbers A, B, C, you will find that A into B plus C is equal to A into B plus A into C. Or if you consider rational numbers like this, A by B, C by D, E by F. If you take three rational numbers like this, then you will see that A by B into C by D plus E by F is equal to A by B into C by D plus A by B into E by F. Same thing for subtraction. Same thing for subtraction. You will see that when we have three rational numbers A, B, and C, A into B minus C. Here we have B plus C. So here B minus C. But see, here we have multiplication with addition. Here we have multiplication with subtraction. That's why multiplication over addition, multiplication over subtraction, because here we have multiplication with addition. Here we have multiplication with subtraction. So multiplication over subtraction. This is multiplication over addition. So when you have three rational numbers A, B, and C, A into B minus C is equal to A into B minus A into C. Or if you take the rational numbers as A by B, C by D, E by F, you will see that A by B into C by D minus E by F is equal to A by B into C by D minus A by B into E by F. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
If you see, when you want to express yourself, then you should know all this. See, sometimes we'll know we can work, but you cannot express. Like if you have to teach your friend, you know, you might find it difficult to say, but you will understand. You might be very good at it. So if you want to express, you should understand this also. When you use distributivity, you split the product as a sum or difference of two products. When you use distributivity, that is the distributive property, you are splitting a product. Yeah, see here we have a product here. We have a product here, A into B plus C. A and B plus C. And it's multiplied. We have a product. Here also, we have A and B minus C multiplied. We have a product. We have a product. You split the product. Yeah, we are splitting. See here, we are split it. We are split it into two. We split the product as a sum or difference of two products, as a sum or difference of two products. See, there's one product here and another product here. There's one product here, another product here. So sum of two products. Where is the sum of two products? This is the sum. This is one product. This is the other product. Sum of two products. Difference of, this is one product. This is the other product. Difference of two products. You have, so you split one product. You're splitting one product. Here we had only one product. Here we have two products. Here you have only one product. Here you have two products. So you're splitting one product. You're splitting it into two products. As a sum of two products or as a difference of two products. So now read this. When you use distributivity, you split a product. This is the product. You're splitting one product as a sum or difference, of two products. This is 1, 2. This is 1, 2 of two products. Yes, children, I don't want, this is very important, so I will not ask you to take a screenshot. Please write down now in the class. Or if you complete this in the class now, as you write, please understand what you're writing.
Ma'am, for distributive property, again, we will not use any rationals.
Sorry, for distributive property, we will not use
Non-zero rationals.
whether it works for non-zero rationals. That is for zero, is it?
No, ma'am, I'm asking we should not use non-zero rationals in this distributive property.
You can. One of the numbers can be zero. The denominator in any number, the denominator should not be zero. One of the rational numbers can be zero. It will still work.
Yes, ma'am.
We'll take a sum in the next class and check that.
Okay.
Yeah. Just remind me, that's all. Now it's time. We can't take an example and check. One of the numbers can be zero. Please write carefully, children. You can write distributive property or distributivity. Both are the same. Distributivity or distributive property of multiplication over addition of rational numbers. Done, children? Still writing, all of you? Right. Okay, yeah. Is it over, children?
Yes, ma'am, completed.
Okay.
Yes, ma'am. Done, ma'am.
All right. All right, children.
Last point, ma'am.
Okay. Danya finished?
Finished, ma'am.
Very good. Yes, children. For the rest of it, you have to take a screenshot because it's getting late for you also. All right, children. So that's it for today's session. Let me just show you one more thing. 1 minute.
Yes, ma'am.
Just try this. Yeah, do verification. You can just try. Do 1 and 2 as homework. 1 and 2 homework. Take a screenshot and try 1 and 2 as homework. We'll see the answers in the next class. Children, discussing homework, you have to remind me. I'm very sorry to say that I'll just forget. You have to remind me before 5 minutes before the class. Open your notebook and see what homework has to be discussed, and please remind me. Am I audible?
Yes, ma'am, you are.
Yes, ma'am.
Yes, ma'am.
All right. Took a screenshot, children?
Yes, ma'am, took.
Yes, ma'am.
Yes, ma'am.
All right, children. Harshita, alone, stay back after the class. All right, children. So that's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you. Good
Thank
night.
you, ma'am.
Thank you. Good night.
Thank you, ma'am.